So as we are waiting for the audience to join, allow me to do a brief introduction. And hi everyone, welcome to the VeloDB webinar. And again, VeloDB is the commercial provider of Apache Doris, and many of the founding team members of VeloDB are also the key developers of Apache Doris, including Kang, one of our guest speakers today. So he goes by the name as Kang as it shows on the slides here, so you can reach out to him on the Doris community on Slack or on GitHub.
Everyone.
Hi. So during the past year in the Doris community, we noticed an increasing number of users seeking to migrate from Elasticsearch to Apache Doris. And this is, of course, thanks to the hard work of the Doris dev team, who has contributed great features to Doris in terms of semi-structured data analysis, including the newly introduced data type, which is called variant, and it has been a big surprise for many Doris users. And now, after a year of continuous improvement and optimization, it's safe to say that Doris has become a well-developed solution for semi-structured data analysis, and it performs really well in many users' production environment. So naturally, many would wonder how Doris compares to the common choice on the market. And in this case, we are talking about Elasticsearch. So today we have Kang and Kevin to give us a well-rounded understanding. Kang has been leading the development of Doris in semi-structured data analysis. He is one of the biggest driving forces behind Doris improvement in this area. And Kevin has provided technical assistance for many users in their migration to Doris. So he has lots of hands-on experience to share. So I think now we are all ready to hear from Kang. So hey, please take over.
Okay, thank you. Hello, everyone. I'm Kang from Apache Doris open source community. I'm a PMC member of this project, and I focus on inverted index and semi-structured data analysis. Today, I will talk about why Apache Doris is better alternative to Elasticsearch for real-time analytics. Before dive into the deep comparison between Doris and Elasticsearch, I will introduce why and how to compare them. And at last, I will show many typical real-life use cases. Apache Doris and Elasticsearch sound like different tools, so why we are comparing them? Actually, they are used for very similar use cases. Let's take a look. Apache Doris is a real-time data warehouse commonly used for observability, cybersecurity analysis, online reports, custom profile, and data lakehouse, and more scenarios. On the other hand, Elasticsearch is more like a search engine, but it is also widely used for data analytics. There is an overlap in their use cases, which is real-time analytics. So the comparison will focus on real-time analytics capabilities. We will compare Doris and Elasticsearch from a user-oriented perspective. So, what's users' biggest concerns when they are facing these two options? First of all, I think since they are both open source products, you might want to know which open source license they are governed by, because this will decide the level of openness of the product and further decide whether you will be trapped in a vendor lock-in situation. And second, you might want to know what the system architecture looks like, because this will decide how you can deploy it, what requirements must be met, such as software and hardware environment. Then you might ask, for real-time data, in which way can data be imported to system, and how can data be stored? And most importantly, what kind of query capabilities can the system provide and how fast can it run? I think this will be the most important questions for users before they decide on a real-time data analytics product. Next, I will look into them one by one. Firstly, both Doris and Elasticsearch are great open source products. The difference is Doris is operated under the Apache Software Foundation and is governed by Apache License 2.0. It is a highly liberal open source license. Anyone can freely use, modify, and distribute Apache Doris, including in open source or commercial projects. As for Elasticsearch, it was subject to Apache License 2.0 at the very beginning. Then, in 2021, it switched to the Elastic license, mostly because some cloud service providers were providing Elasticsearch as a managed service, and the Elastic company tried to protect its business interest and moved to the Elastic license in order to restrict certain commercial use. And then in 2024, just a few months ago, Elasticsearch announced that it would be open source again by switching to the AGPL license. And this license has less restrictions on cloud providers. So the difference in licenses actually means differences in the way the two open source projects run and operate. Apache Doris, as the name implies, is managed by the Apache Software Foundation and follows the Apache way. It will always be an Apache license and maintain the high level of openness. On the other hand, Elasticsearch is owned and run by Elastic Company, so it is free to change its license based on the changing needs of the company. I believe that's why many large companies and cloud providers prefer Apache projects over other open source products. Second of all, the architecture of Doris and Elasticsearch decide the ways of users to deploy them, and also decide the kind of requirements on the underlying environment. Doris supports various development models, especially after the release of version 3.0. It can be deployed on-premise in the traditional way, which means compute and storage are integrated with the same hardware. It can also be deployed on the cloud with compute and storage decoupled. It even supports BYOC model, which means that you can deploy Doris on your own cloud resources and benefit from cloud providers' management tools to run the databases. Elasticsearch supports on-premise and cloud deployment, but so far it doesn't support the BYOC model. And as I just mentioned, Doris supports compute storage decoupled model since version 3.0. This means Doris provides higher flexibility and elasticity. So far, Doris provides various kinds of isolation. It allows you to isolate your computing workloads. That means it is good for multi-tenancy. It allows you to decouple compute and storage, and it also provides tiered storage so that you can choose different storage medium for your hot and cold data. As for Elasticsearch, it only supports the traditional deployment mode and does not allow you to decouple compute and storage with the open source option. In terms of workload isolation, Doris provides the workload group mechanism. It is implemented by Linux C groups, which offer hard strict isolation. However, Elasticsearch implements workload isolations by thread groups, which only provides limited soft isolations. As a user, after you finish deploying the system, you might think about how to write data into it. Doris and Elasticsearch are very different in data ingestion. Doris, as a real-time data warehouse, supports real-time data writes and updates. One of the standout features of Doris is its incredibly high throughput for data writing. This is because we have put a lot of effort in optimizing it, such as single replica indexing. I will provide some test results to show you how fast it is. But on the other hand, people often criticize Elasticsearch for its low write throughput. It is actually a well-known pain point. The low write throughput of Elasticsearch is because it needs to generate very complex inverted index and write multiple index for multiple replicas, which cause a lot of overheads. Normally, there are two ways to write real-time data into a data system. One is push-based and the other is pull-based. A push-based means user actively push data into a system, such as via HTTP. A pull-based method, for example, is where Doris pulls data from Kafka message queue. Elasticsearch only supports pull-based ingestion, but it requires Logstash to perform pull-based data ingestion, so it's less convenient. Additionally, a Logstash output plugin is available for Doris, enabling seamless data ingestion from Logstash into Doris, and the same story for beats. Now, let's take a look at real-time storage capabilities. Doris provides 3 data models. As for Elasticsearch, I put it as 2.5 because it only provides limited support for certain data storage models. I will get into them one by one. The first data model is duplicate model, which means it allows data duplications. It is suitable for storing logs. Both Doris and Elasticsearch support this model. The second is the primary key model. It works like OLTP databases, which means the data will be deduplicated by key. And there are more differences between Doris and Elasticsearch in terms of the primary key model. The third is aggregation model, which means data will be aggregated or wrapped. I will provide more details on the primary key and aggregation models. The primary key model in Doris is called unique key. It provides very high performance and many great features. Just like many databases, you can define one or multiple fields as a primary key for data duplication. It can deliver fast write speed. More importantly, if you need to do deduplication during data writing, it will not cause you a huge performance loss, just about 10%. However, in Elasticsearch, you can only use one field as a primary key, or unique ID called unique ID, and it cannot be used for aggregation or sorting. So you will need to combine multiple fields into one before you can use them as a primary key. In Elasticsearch, if you use a unique key as a primary key, unique ID as a primary key, you will get much slower data writing. As you can see from the tests, The left one is done with HTTP logs as a dataset. The other is the custom table from TPC-H benchmark. In Doris, duplicated data writing is only about 10% slower than duplicate data writing. But in Elasticsearch, the performance gap is much bigger. It can be 3 times slower. So when deduplicated data writing is the common case for you, Apache Doris is definitely a better choice. As for the aggregation model, Doris provides a lot of powerful and user-friendly features. It ensures strong consistency for aggregated data and the original data. It supports data updates, and you can keep both the original data and the aggregated data, or you can only keep the aggregated data. On the other hand, data aggregation in Elasticsearch is an asynchronous process. No matter you use rollup or sample mechanism. Once the data is aggregated, you can no longer update it. And you can only keep the aggregated data and say goodbye to your original data. So now you know that why I said it only supports 2.5 data models. Its primary key and aggregation model lacks some basic features and capabilities. Now, speaking of data storage, a big concern for users is storage space consumption, or more straightforward, storage costs. This is another pain point of Elasticsearch. It creates huge storage costs. To learn from this lesson, we have made a lot of optimizations on Doris and have successfully reduced the storage cost by a lot. I will prove this by some of our tests and use cases later. These optimizations include simplifying the inverted index. Doris has support inverted index since version 2.0, and we have put a lot of work to make it simpler and take up much less space. As for data compression, Doris supports the ZSTD algorithm. It is much more efficient than GZ and LZ4. Generally, Doris can reach a high data compression rate of 5 to 1 or 10 to 1, and Elasticsearch can only reach 1.5 to 1. So that means Doris is 3 to 5 times more efficient than Elasticsearch in data compression. These are some benchmarks tests to show you the difference. The left one is done using the official testing tool for Elasticsearch called ESRally. The other is done with the Azure Logsbench dataset. Both tests show that Doris is about 4 times faster than Elasticsearch in data writing, but only use 1/5 of the storage space that Elasticsearch uses. That means you can reduce your storage cost by 80% if you migrate from Elasticsearch to Doris. Then, for data queries, Doris is more than 2 times faster than Elasticsearch. I will explain them later. In most cases, you often need to update or modify the data schema, especially for online business scenarios. This requires you to do schema changes. Elasticsearch claims to be schemaless to support flexible schema, but it only allows you to dynamically add columns. For example, when you write JSON data into Elasticsearch, if the data contains a new field, Elasticsearch will create a new column in the schema. So you don't need to define the new schema beforehand. like you do in traditional databases. However, flexible schema change is much more than that. There are a lot of needs that Elasticsearch does not satisfy. For example, if you need to delete a field from the table, you cannot do that in Elasticsearch directly. You have to do a reindex operation that read and write the entire index in Elasticsearch. Also, if you have 100 fields in the table and you have created inverted index for 10 of them, and then 2 days later, you want to add inverted index for another 5 fields. But no, Elasticsearch does not allow you to do that. Similarly, deleting index for a field is not allowed either. So to avoid such troubles, most Elasticsearch users will just create inverted index for all of their fields. But that causes much slower data ingestion and much larger storage usage. And more, Elasticsearch does not allow you to modify your index and field names. To sum up, if you need to make any changes to your data, you will need to reindex everything. This is highly resource-intensive and time-consuming operation, and that's also a huge burden for users. But Doris supports all of these schema changes. You can add fields or delete fields as you want. The changes can be finished in just a few minutes, seconds. You can add or delete indexes. You can change the name of any table or field very easily. This kind of flexibility will save you a lot of time and effort, especially when you have changing business needs. Finally, let's take a look at queries. After all, once the data is written into the system, the main goal is to support efficient querying, right? So the first thing we need to evaluate is how easy it is to use the query features. Does it offer convenience and flexibility for users? Secondly, we look into its capabilities. What kinds of queries can it handle? And finally, we consider its performance. How fast is it when executing queries? Firstly, let's talk about usability. One key aspect of usability is reflected in the design of interface. Apache Doris is an analytic database and real-time data warehouse. It provides a standard SQL interface and is compatible with MySQL. The benefit of this is that the learning curve is very low. A large number of engineers are already familiar with MySQL, and there is a big ecosystem and many software tools that are compatible with MySQL. This makes Doris super convenient to adopt and integrate. But on the other hand, Elasticsearch has its own domain-specific language called DSL, which is especially designed for search. This DSL is part of the Elasticsearch ecosystem, which means the learning curve is much deeper. It often requires engineers to invest a lot of time and effort to fully understand and use the DSL efficiently. Let's look at an concrete example. Imagine that you want to specify a time range to search for a particular keyword. After that, we group and order the data by time interval to visualize it as a trend chart. In Doris, we can do this with only 7 lines of SQL, as you can see on the left. However, in Elasticsearch, the process requires 30 lines, not just the lines of code. I believe many of you relate to this. The first time you try to than Elasticsearch DSL. It can feel quite challenging, and moreover, even you are familiar with it, when you want to write a query, you often have to refer to document and examples. It is difficult to write DSL queries from scratch because of its complexity. In contrast, SQL is simple, clear, and highly structured. Most engineers can easily write a query like this without much effort. So it is far more user-friendly for most use cases. Then, let's move on to query capabilities. Elasticsearch is very good at searching. As its name suggests, it was built for search. So it has very strong searching capabilities. Yet, Doris has been improving its searching capabilities since version 2.0. We have introduced inverted index and full text search in C++. So Doris is quite competitive in this area too. Elasticsearch is exceptional in searching, but beyond search and aggregation queries, it does not provide features like multi-table join and complex analytical queries. On the other hand, Doris is a general-purpose data warehouse. It provides strong capabilities for complex analytics, including multi-table join. Here on the slides, I listed various types of joins and the optimizations and the wood. Beyond this, Doris also supports advanced analytical features. For example, you can write UDFs, create subqueries, build materialized views, or acceleration query lakehouse. These are features that Elasticsearch simply cannot provide. Finally, let's take a look at query performance. We have extensively optimized Doris for multiple scenarios, so Doris can deliver high performance in many use cases. For example, in high concurrency point queries, Doris can achieve tens of thousands of QPS. When it comes to aggregation analysis, Doris stands out as a global leader. Elasticsearch is mainly good at point queries, especially when retrieving just a small amount of data. However, when it comes to complex analytical workloads, Elasticsearch can face significant limitations. For comparison, let's take a look at some data from Geekbench. Here is the performance differences between Doris and Elasticsearch. The key metric here is relative query time, where lower is better. So if we set Doris relative time as 1, then Elasticsearch out-of-box relative time will be 20, which means that it is 20 times slower than Doris. Even after optimization, Elasticsearch improves, but it is still more than 6 times slower than Doris. All right. So far, we have compared Doris and Elasticsearch in 5 aspects. In summary, Doris follows Apache license 2.0. It is highly open license and ensures that Doris remains truly open and will continue to uphold this openness in the future. Secondly, Doris can basically run everywhere. It can be deployed in virtual machines, physical machines, Kubernetes, and on the cloud. So it provides a lot of options for users. Thirdly, Doris provides high performance in data ingestion. It is usually 3 to 5 times faster than Elasticsearch. In terms of storage, compared to Elasticsearch, Doris can reduce storage cost by 70% or even more. It is also 10 times faster than Elasticsearch in data updates. As for data queries, as I just mentioned, Doris outperforms Elasticsearch by a lot. Also, it provides analytic capabilities than Elasticsearch, including multi-table join, materialized views, data lakehouse, and many more. Okay, so far we have compared Doris and Elasticsearch from both user's perspective and technical perspective. But how they performed in real-life use cases, let's take a look. When users compare Doris and Elasticsearch or considering replacing Elasticsearch with Doris, they focus on 3 main scenarios: observability, cybersecurity, and business analysis. I will share 3 user stories from each of these scenarios. So there will be 9 cases in total. In the future, we will provide more detailed examples for your reference. So stay tuned with us. The first case is from a world-famous short video provider. I'm sure you will be shocked by their data size. 500 terabytes per day. The peak write speed reaches almost 100 gigabytes per second. I believe there are only very few systems in the world that can handle such huge throughput, and Doris is absolutely one of them. The second case is about NetEase. It is also a world-leading internet company. NetEase replaced Elasticsearch with Apache Doris for log analysis. As a result, it reduced its storage cost by 2/3 and achieved 10 times higher query performance. NetEase also replaced InfluxDB with Doris for time series data analysis and achieved great outcomes, reduced half of their server resources. The third case is from an observability platform provider. It used Doris to replace Elasticsearch on the cloud. According to the user, the end-to-end cost on the cloud, which means the actually money they pay out of pocket, is 17% lower after they migrate from Elasticsearch to Doris. That's a remarkable cost reduction. Plus, they increase the system's query performance by 1 to 3 times. So it is not only a high-performance solution, but also a high-cost effective solution. Then let's look at use cases in cybersecurity. The first use based on use Doris for log storage and analysis. Their storage consumption reduced by 40% and their write performance doubled. The user especially values Doris for its ability to perform full text search, aggregation, and multi-table joins in one system. The second case is from a payment platform. As you know, the payment industry places a very high priority on security. In the past, they rely on multiple components like Presto, Hive, and Elasticsearch to handle their complex security analysis. Then, they adopted Doris as an unified solution. After that, they have seen big improvements in data writes and query performance and storage efficiency. The third case is also an excellent cybersecurity solution provider. In this case, Doris provides 2 times higher write throughput and 4 times higher data compression ratio, and it saves a lot of storage space for the user. Then, the user tested Doris and Elasticsearch using 41 queries. In general, Doris is 4 times faster than Elasticsearch. Then, let's move on to business real-time analysis. This case is from a famous e-commerce user. It is not only a short video company, but also a live commerce provider. Previously, they rely on Elasticsearch to handle online queries for their live stream detail pages, but they face big challenges in cost and concurrency. After replacing Elasticsearch with Doris, their write performance improved from 300,000 write per second to 1 million write per second. Meanwhile, query concurrency increased from 500 QPS to over 2,000 QPS. The second case is from Tencent Music Entertainment. It used both from Elasticsearch and ClickHouse to meet their needs for data searching and analysis. But managing 2 separate systems was complex and inefficient. With Doris, they are able to unify these 2 systems into one single platform to support both data searching and analysis. Additionally, they save a lot of storage cost and can handle more complex analytical tasks. The last case is from a security web browser provider. They need to handle both log retrieval and report analysis. They use Doris to unify Elasticsearch and other systems into a single platform. This greatly improves their query efficiency. Also, because Doris supports SQL, using SQL also improves their development efficiency by 100%. So they have more time to drive business innovations. So far, I just shared some of our typical use cases. In fact, we have many more users and successful user stories to tell. You can join the Apache Doris community on Slack, and you can have further discussions there. I'd like to share a bit of our development journey with you. The path to making Doris good enough to replace Elasticsearch wasn't easy. Back in 2022, we started adding inverted index capabilities to Doris. At that point of time, many people questioned this decision. They saw inverted index as Elasticsearch's sin, a feature no one else in the industry dares to do. People ask that, why are you doing this feature in Doris? And no one believed we could succeed. But we went with it anyway. And today, we can say with confidence that we made it. In 2022, we built this feature from zero to one, and after a year of effort, we open sourced it. Initially, we had only one user who are willing to test and use it. I'm very grateful to them for supporting us during that very early stage. By 2023, more users began to see the value of Doris with inverted index, that's how we skewed from 1 to 10. About 10 companies adopt it. The momentum keeps going. Now in 2024, we are experiencing rapid growth, and more than 100 companies use Doris to replace Elasticsearch. Looking ahead, I'm very confident about what 2025 will bring. This progress from zero to so many has been made possible by incredible support from Doris community. So thank you so much to all of you, and welcome more new users. For the next
Thank you
phase,
so
we
much.
will we will need even more support from our community and users to bring Doris to even greater heights. So welcome to join us. That's all. Thank you.
Thanks a lot. And that sounds really exciting. And I am seeing some questions from the audience in the comment section, and I am not sure if you can see them, so I copy and paste and send it to the comment section in Zoom, so for your convenience. And question number one is from Suresh, and he is a data management expert. And welcome. And he asks, will Doris support all features of Lucene query capability on text data if we use inverted index on a column? For example, like you want proximity search, example like you want to search Apache and Lucene with only 10 words between those two words. Can we do that in Doris?
Okay, this feature is called Snope. It's called Snope in phrase query. It is already supported by Doris version 2.1 and 3.0. And more, Doris will support the mostly used features in Elasticsearch, but not all. We will support most of them. We will focus on the three usage scenarios I mentioned earlier: observability, such as log trees and metrics, cybersecurity, and business analysis. For text search, we only support the most used features, but the one you mentioned is already supported.
Yes. That's also great. So, and question number two is from Pam, and he asks us for the slice. So I believe we also think the slides are very informative and useful, and we'll need it for further reference, and it provides a lot of useful information. So I will DM Pam on LinkedIn and send him the slides after this live. So and if other audience have questions for the speaker, you can also send it in the comment section or even after this live event. So, and I personally also have some questions for you, because as I mentioned earlier, that many users this year have been looking to migrate from Elasticsearch to Doris, and I'm sure other users would be curious about why they want to make the change, what makes them want to replace Elasticsearch, what are the biggest challenges or issues they are facing with Elasticsearch, what are the pain points?
Okay, Elasticsearch has two common pain points. The first one is high cost, and the other is limited analytical capabilities, as I mentioned in my slides. The high cost mainly comes from the high CPU resource consumption during data writes and large storage space usage. Elasticsearch stores original data, inverted index, and doc value as column storage data. So it consumes much storage space than Doris. Elasticsearch is originally designed for text search, so it has limited analytical capabilities. It does not support complex analysis, just like multi-table joins, materialized views, and data lakehouse analysis. So it is not suitable for use cases such as data warehouse layering, processing, and federated queries. So I think high cost and limited analytical capabilities is the two main pain points for Elasticsearch users.
I see. So, when you're looking for better analytical capabilities and lower costs, you should definitely try Apache Doris. And my next question for you is, last year we've seen great improvements of Doris in terms of semi-structured data analysis or log management and analysis. So, what can we expect for 2025? What are the development plans in this area?
Okay. Firstly, we will strengthen the integration of Apache Doris with the observability ecosystem, like Open Telemetry, Giga, Grafana, and more, because we want to allow users to use Doris as a storage and analytical foundation for their observability stack more easily. Secondly, we will continue to focus on performance and cost. We will keep on improving write and query performance and keep on reducing the storage usage of Doris. And thirdly, we will optimize the semi-structured data type called variant. Currently, user can store JSON data in variant and benefit from the advantages of column storage, just like high compression ratio and high performance. In the future, the community will continue to improve this feature. We want to enable variant to be better support thousands or even tens of thousands sparse columns and better support for inverted index. Okay, I think
Yeah.
these are the main directions in this year.
Yeah, those sounds very promising, and we look forward to all of them. And a special thanks to you and the team for your hard work that makes Stars what it is today, and thank you for your efforts to make it even better. And and then I have my third question is for Kevin, because you are a senior solution architect and you have helped many Doors users in production. So, and as I talk to many users in the community, I find that some of them are attracted by what Doris can do, and they want to give Doris a try. But it's not easy for them to convince the rest of their team or convince management. And it's not easy for an organization to make the change, especially those big companies. And because they have already invested a lot of efforts into the old system, and everybody is so used to what they have right now. But the change might be exactly what they need um, for big companies because the bigger data set you have and the more complex analysis you need to do, the more you will benefit from the migration to Doris, just like Kang has just introduced. So my question for you is it easy to migrate from Elasticsearch to Doris, and how does the migration go like?
Okay, so usually, so we can consider the migration from three layers of task to be done. So the first layer is about the metadata conversion. most data types are the same in these two platforms, but still there are few, such like converting byte in Elasticsearch to tiny int data type in Doris, or like converting short to semantic int. And the second layer is about the data conversion and the migration. Also, there are multiple methods here. So the first method we can leverage catalog insert can be used. For example, we can pull catalog select from ES catalog table. And the second method is about we can leverage multiple migration tools in this market to help us. So such like DataX and Citalo, these kind of the tools can help us to migration the data. And also, the third method is about setting up the parallel running environment. So in log analysis scenarios, as time passes, the value of data will decrease. So however, the project implementation is to be comprehensively considered based on the actual data timeliness and the business requirements. About the third layer is the syntax conversion. Doris is compatible with the standard MySQL syntax. So however, Elastical has its own very unique syntax. So such like equal is the term inquiry in Elasticsearch, and is the borrow filter in Elasticsearch. So some conversions are needed to be done for these different syntaxes while collecting up-layer applications. So we can have our projects from these third layers. Anyway, so I think our current users can see the big effects and the advantages from migration Elasticsearch to Doris platform.
Great, thanks. And is there any best practices or suggestions you would like to share with us? Something that might be helpful for users who try to migrate to Doris or use Doris in semi-structured data analysis? If you can name a few so far.
Yeah, as I just said, it is a very comprehensive question. So generally, the scenario analysis is the most important. So we need to understand the features, how our customers leverage Elasticsearch and the Doris platform, so that we can see and the most suitable and cost-effective way for the migration. So anyway, so while our users migrate to Doris platform, so they can see the better performance, less storage capability, and easy to use.
Yeah, that's case specific, and it's exactly what you do, and you have accumulated very valuable experiences in this area as you help the Doris users. And I'd also want to thank you for your contributions, for all the help you have provided for the Doris open source users. So I am seeing no more questions from the audience. And it's been a really informative hour. And big thanks to Kang and Kevin for the sharing. And if you want to seek more advice from them, you can reach out to them in the Doris community on Slack, where you can also meet more users of Doris and developers. And we look forward to seeing you in our future discussions. Goodbye and wish you an awesome 2025.
Thank you. Goodbye.